everyone, Marcus here from learndatascheme.com. So in the last video, I show you how to load in the turnover dataset, and then we look at all the different columns in this dataset, and then I explained what they are about. So in this tutorial, we're going to look at some visualization with using Seaborn. We're going to plot some graph and heat map and to further understand the data before we want to use the statsmodel API to get some insights from the data. And then finally, we are going to train the model, and then we are also going to do some predictions. So without further ado, let's look at how we want to do that. So the first thing that we want to do here is to write some code to create a heat map. So this is a step 4 of our exploratory data analysis, in which we use a function in the Seaborn to define the size of the heat map. And then we also define that we want the heat map to present the content in terms of correlationship between the variables, and then we want it to be in red color with some annotations. Let's go ahead and run this. So if you run this, you will see that we have generated a beautiful heat map chart with some labels in the X and Y axis, and then we can see that from this heat map we can tell that there is some correlationship between the left and the satisfaction level, and then there is probably some correlationship between the left with the experience in the company or probably work accident. And then we can also see that the last evaluation is very strongly correlated to the number of projects or the average monthly hours. For example, somebody has a bad evaluation if their average monthly hours is high or they have a lot of projects. So average monthly hours is also correlated to number of projects. For example, if you have 5 to 6 and 7 projects, definitely your average monthly hours is going to be high. So from this heat map table, we can actually get some insightful information about the interrelationship between different variables. So the next thing that we want to do is to create some bar plot or cow plot with using Seaborn as well to further analyze and get better understanding of the data. For example, we're going to plot a cow plot of different functions in the company. We're also going to plot a cow plot of how many people has left the company based on different functions or number of projects and satisfaction level and so on. So let's go ahead and see how we can do that. So first we are going to create a cow plot. And then the cow plot will be based on different roles in the company, and then just go ahead and run this. So you can see that we're able to see how many people are in different functions, including sales, accounting, human resource, and so on. And most of the people are actually in sales department in this company, and also majority of people are in technical and support department. So the next thing that we want to do is probably to plot based on different function, but then this time we are going to add in additional factor or variable, which is the salary range. So you can see that I have added in an additional variable of hue equal to row into this plot, and then from here we can see that we have x-axis in salary with low salary, medium salary, and high salary, and then they are further divided into different functions. So from here we can actually tell that most of the people in the sales department has low salary, and then probably if you look at management, most of the people have high salary in the management functions. And after that, we may also want to look at how many people has left the company based on their salary range. So to do that, what you need to do is to use back the same set of code, but then you just need to change the row into left. So to do that, I will just copy the code here so that you can see. So low salary, medium salary, high salary, but then you can see that more proportion of people in the low salary range has left the company. 1 means left, 0 means still in the company. And to further explore the data, we can actually do one more, which is the number of project, for example. So you can see from this count plot, the distribution is a bit weird. So we can see that in this company, the people with less number of project, which is 2 project, has large proportion that has left. And then for those which 7 project, all of them has left. And then you can see the trend is of leaving the company is increasing as you increase the number of projects. So this could be one of the insightful information that we want to get in data science. And we can also do the distribution plot, because in data science you always want to see the distribution of the data points across different variables. So to do that, I've also prepared a set of code which you can use. For example, here we are going to plot one row with 3 columns with their width times height. This is the size that of the plot that we want to create later. And then this plot means distribution plot. We are going to look at the distribution for the satisfaction level. Last iteration also, we are going to look at the average monthly hours. So go ahead and run this. And we can see that most of the people in this company are at the high satisfaction level, even though there is also probably a cluster of people with a low satisfaction level. And then the last evaluation is distributed mainly on around 0.5 and also at the high side. And for the average monthly hours, we can see that the highest contribution will be around 150 and also around 250. So if we come back and look at our data set again, df.head, we can see that we have row and salary which are in the object data type. So we have to change this into integer or float, otherwise our model will not be able to use it for the purpose of the logistic function. So we have to do the same thing as what we have done before, except that we will first draw up the names, because the name definitely is not going to contribute to whether a people is going to leave a company or not. So we're going to draw out the name before we do the label encoder function. So yeah, this line of code allow us to draw the name, and then we create a new object data frame from the original data frame, but then we only select the row and salary which are in the object format. And then the next thing we're going to use the scikit-learn library package, and then we will use the pre-processing function label encoder, and from here we create new columns based on the old columns. So we're going to create row new and salary new. And then after that, if you go ahead and say df.head, you can see that now we have 2 new columns, row new and salary new, and the number is assigned based on the row. For example, number 7 is referring to sales, number 6 is probably referred to technical, number 5 is probably referred to management, and then salary new, number 1 is referring to low, number 2 is referring to medium, and probably number 0 is referring to high. So now in this row and salary column, we can actually go ahead and drop them because we don't need them in our logistic function later. So to do that, we can say df.drop, and then we want to draw the row. We also want to drop the salary, and then 1 is referring to columns, and then we are going to say in place equals true. So df.hit again to make sure we have dropped them successfully. Yes. So now if you run df.info again, you can see that we only have float and integer data type in our data set, which is good. So the next thing that we want to do is to use the stats model API, which I have shown you just now. We're going to use the Logit model. So to do that, we're going to import the stats model API as SMF. Then we're going to use the Logit function, and then our formula will be left as a function of satisfaction level, number of project. We are going to put in everything. Yeah, so I missed out one, which is the salary new dot fit, and then go ahead and run this, and then we're going to say we're going to look at the summary of this the statistical model dot summary. So from here we can actually see that the first thing we want to look at is the p-value. We want this to be less than 0.05. For salary new, you can see that it's more than 0.05, so we want to drop out these independent variables. The next thing, yeah, let's first drop out this salary new to and then run the summary again. Probably I'm just going to delete from here, and then go ahead and run this, and then run this. Yeah, so we have all the variables with p-value less than 0.05, and then the next thing that you will want to look at is the pseudo R squared value. So in the linear regression tutorial, I show you how you can use R squared to determine how good is your model, and then for logistic regression, we actually have to look at R squared as well, but then for logistic regression, we actually have a pseudo R squared value. So if you Google about it, you can see that some people are talking about actually the pseudo R squared value should be something between 0.2 to 0.4, which indicates excellent model fit. And in our example, we have a value of 0.197, which is, I think, pretty good. So which means we can actually keep all these variables in our formula to predict whether people will leave the company or not. So yeah, seems like pretty good. And then the next thing that we can do is to proceed to the next step, which is the step 5, train the model. Okay, to train the model, we will use logistic regression from scikit-learn, and I'm just going to copy paste because they are quite a number of codes that you have to write here. I don't want to waste time to just let you to see I'm typing the code all the way. So I want to spend more time on explaining the concept we have this code to you. So for scikit-learn linear model, import logistic regression, and then we are going to import the pre-processing because we want to scale the our independent variable later, and then the columns that we are going to use to predict the left are all these columns, except the left column is our response variable. So we are going to say that X is our data frame with all these columns, and then we are going to scale our X, and then the Y is referring to the left column, which is our dependent variable. And then the last thing that we want to do after this is to train our model. Since we already have our x and y, then we can from scikit-learn.metrics import accuracy score, and then we define our log model is logistic regression instantiation, and then .fit will train our model, and then we can calculate the accuracy of our model with using .score. So let's go ahead and run that. So you can see that our model is actually around 76.61% accurate, and yeah, I think we have done the training of our model, and actually the score is quite good. And then I want to stop here for this video, and in the next video I'm going to show you how you can use this model to predict whether people will leave a company or not, because we're going to use the test data set. And then I will give additional bonus session in which I'm going to show you how you can run machine learning without using any coding at all. So if you're interested to learn that, stay tuned, and I will see you in the next video.